Hi, Dr. Pat here. We're doing another example of system of equations. So we're basically starting off with two equations, and we've got two variables, an x and y in this case. Doesn't have to be x, y. It could be any letter variable you want. It could be p's and q's, z's and w's. Doesn't matter. So long as we got two equations, two variables, and as long as they're not parallel lines, we'll get a solution. Okay, so now how do we solve this? One of the things I want to bring your attention to is you might be looking at that second equation and some people are looking at, oh my God, that's decimals. I just don't like them. Oh, and it's looking awkward. That's okay. We can do just like Photoshop. So we're going to do the math version of Photoshop, the before and after kind of things. So I'm looking at those decimals in that second equation and some people are freaking out and he's like, hey, I don't want to deal with them. I wish I could do this for relationships, but hey, if I don't want to deal with it, we could avoid it, but we don't want to avoid it. We actually want to do something about it. And so one thing that we could do is we can take that second equation and we can multiply it by 10. As long as we multiply each portion of this, each part of this equation by 10, we're allowed to do that because of the equal sign. We can leave the first equation alone. Don't have to do both equations. I can do one equation. As long as I multiply both sides of the equation by it, we can do that. So what we're doing here is getting rid of the decimals. That sometimes freaks people out. You can do the same thing with fractions, by the way. And so we're getting rid of those things by one equation at a time. And now we're ready to do, I'm going to do elimination method to solve this, just because it's a method that really makes a good connection with what we do with matrices. So I'm kind of setting this up for later on. Now we've got our equations, and what I want to do is I want to set it up. I want to manipulate it. It's one of the things you want to do as a math person, this perspective of manipulate the bejeebies out of any kind of formulas that you want. You can do that. So just kind of work it so that it's convenient for you. That's what we math people do. We manipulate all the time. Now, what I want to do is I want to get this equation and use the elimination method. I want to get the x's, and you can do this with y's. But I'm just choosing to do with the x's. So here's what I want to do. I want to have x's have the same number but opposite signs so that when I combine them together, I get a 0x. Okay, that's our goal. Same number but opposite signs. So here's what I'm going to do. I'm going to multiply the first equation by -3. That's going to give me a -6. Then I'm going to multiply the second equation by 2. That'll give me a +6. So I'm going to have same number, same coefficient for the x, but just opposite signs so that when we eventually add the two equations together, it will be 0. So here's what I get. If I'm multiplying that x by -3, I got to go all the way across there. So that's why you're seeing a -9, and that's why you're seeing a -15. If I'm going to take the second equation, multiply that first thing by 2, I got to do it to everybody else. And so that's why you're seeing a 6x plus 4y equals 10. It's because I'm taking the whole equation and multiplying everybody by 2. Okay, now that I've got my equations ready to go, I'm ready to do the elimination method because I've got these opposite signs, same number, opposite signs. I'm ready to do it. So let's do that elimination method. We're going to work that first column to get a 0x. We're going to work the y's and we're going to work the numbers. So when we combine these two equations together, we get 0x. That means that's going away. -5y equals -5. And so we've just eliminated one of the variables. The next step, we just got to solve for y now. So how about if we multiply both sides of this equation by -5, and then I get a 1. Then we take that 1, pick either of the equations that you want, the two original that we started with, or one of these two. Pick either one, plug in 1 for the y value, and then solve for x. So I'm going to 4 times 1 is 4. I'm going to subtract 4 to both sides so I can cancel that out. Then I want to get rid of this 6. Let's divide both sides by 6 to cancel it out, leaving us a nice x equals 1. And so our solution is 1, 1. And if you graph these two graphs will cross each other at the point 1, 1. Hey, I hope this was helpful. Talk to you later.